Hi class, this is day 16, Friday, April 24th, period 4. This is for grade 12, U and AP. I gave you some homework and I realized after I posted the result, because I got a little bit distracted, that I forgot to add the effects of the original dissociation of the sulfuric acid and the effect of the second dissociation. So if you recall, I asked you to solve a problem, or I solved a problem for you, where you had a solution that contained 0.03 molar sulfuric acid. Because sulfuric acid is a strong acid, in the first dissociation, it fully dissociates. So immediately you're going to have 0.03 molar concentration of protons in a solution if you have a 0.03 molar concentration of sulfuric acid. But because sulfuric acid is a diprotic acid, the second proton also wants to dissociate, but because now it's a weak acid with a Ka sub 2 value of 1.2 times 10 to the minus 2, its ionization is suppressed by the presence of protons already in the solution, but don't worry about that. All you have to worry about is how much additional H plus is dissociated from that second dissociation. I calculated that amount, and then I calculated the pH based only on that amount. So I forgot to add the 0.03 that was already sitting in solution. So I'm going to correct that error now. Like I think I may have made a note about it in the comments. So I'll show you where I went wrong. So what I had was that Ka sub 2, which equals 1.2 times 10 to the negative 2, is going to represent the concentration of sulfate anions, additional protons dissolved from the bisulfate anion, and whatever amount of bisulfate anion remains unionized. So that was represented by X for the sulfate that forms. And then the H plus concentration in solution is going to be 0.03 plus X. But remember, we're solving for X here, okay? We're only solving for X. Once we find X, we've got to remember to add it on to the 0.03 to get the final H plus concentration, or else we'll get the wrong answer, which is what I forgot to do. So what you get is a trinomial that looks like this: X squared plus 4.2 times 10 to the minus 2. X minus 3.6 times 10 to the negative 4, all that equals 0. When you plug that into the quadratic formula, you'll get the following answer: 7.301 943 times 10 to the negative 3. You also get a negative value, 4.901 times 10 to the negative 3. This is the value you're looking at. You discard that. That's not a true answer. So the total concentration of protons is the 0.03 from the first dissociation plus this from the second dissociation. So the total amount of H plus, so that equals the H plus from the second dissociation. So H plus total concentration is 0.03 plus the 7.3019, etc., times 10 to the minus 3. What you get as a total is 3.730194 3 times 10 to the negative 2. And if you take the negative log of that, negative log of H plus concentration gives you the pH. pH therefore equals 1.428, rounds off to 1.43. Okay? There's your final answer for that question. For homework, I asked you to do the same type of calculation, except I just gave you a different concentration of sulfuric acid. So the sulfuric acid concentration I gave you in the homework was 0.0075. By the way, if you know how to solve for the pH of a sulfuric acid solution, you will also know how to solve for the pH of a mixture of a strong acid with a weak acid, because that's exactly what sulfuric acid is. It's a strong acid, and with its second dissociation, it's a weak acid. So whenever you're calculating the pH of a dilute solution of sulfuric acid, you're going to have to use this method. If you have a concentrated solution of sulfuric acid, the second dissociation hardly makes a dent. Because remember, every time the pH decreases by 1, the concentration of H plus is multiplying by 10. It's a logarithmic scale. So if you have a pH difference of 2, say if your pH goes from 5 to 3, that means that your concentration of H plus at pH 3 is 100 times higher than the concentration of H plus at pH equals 5. So the second dissociation becomes less and less important as the concentration of the sulfuric acid goes up. So in most cases, you can probably get away. If the pH is below around 3, you don't have to worry about the second dissociation. Okay? So let's do the homework question now. Same setup as the one I did yesterday, or a couple days ago, because I've been working on your marks, so we haven't had any class because of that. It's too busy. So the question is, what is the pH of a 0.0075 molar H2SO4 solution? Ka sub 2 is equal to 1.2 times 10 to the negative 2. First dissociation is obviously complete because it's a strong acid. So we set up you set up the equation Ka sub 2, which equals 1. Well, let's continue this one. Equals concentration of the sulfate anion times the additional H plus that dissolves over the concentration of bisulfate, which will be exactly equal to 0.0075 before dissociation. If you set up your ice table, you just show the dissociation of bisulfate. And the trinomial you get from that is, let's write in the numbers as well. You'll get 0.0075 plus X for the H plus concentration. I should write the sulfate concentration first because that's how it appears in the equation. So X times 0.0075 plus X all over 0.0075 minus X, because that bisulfate ion concentration, due to the first dissociation being 100%, will be exactly the same concentration as the sulfuric acid, the H2SO4, before you put it in solution. And then why do you get minus X? Because the bisulfate itself also dissociates down to sulfate. That's the second dissociation. That's why we're getting minus X here and plus X over there. You already have 0.0075 molar solution of H plus from the first dissociation, and then the second dissociation gives you a little extra H plus. That's how you represent that. So the trinomial you get from all this, once you distribute it, is X squared plus 1.95 times 10 to the negative 2x minus 9.0 times 10 to the negative 5, and all that equals 0. When you solve for the value of x using the quadratic formula, or in my case I use the quadratic function in my calculator, I got 3.8537 6786 times 10 to the power of negative 3, and I got negative 2.3353 times 10 to the negative 2. This is the number you're interested in. The other one is just can't have a negative concentration, at least not in this situation. So that the H plus concentration total is going to be the 0.0075 plus this number, 3.85376786 times 10 to the minus 3. What that adds up to is 4.6037 6786 times 10 to the negative 2. So that gives you a pH, because pH is equal to negative log of H plus concentration, it gives you a pH of 1.3368. 658. And you're only allowed 3 sig figs, so it comes out to 1.34. That's your pH from that concentration of sulfuric acid. I'm afraid this class is going to have to be a little shorter than normal because the next phase is going to be involving buffers, and I have all those notes at home. I don't want to start rewriting all the notes for that notebook too. I'm going back home this weekend, so I'll proceed teaching from there where I have access to all my notes, and it'll be a lot less stress for me because I'm having to rewrite the notes from scratch and it's taking a lot of time. So finish copying that, and then I'll give you the mock test questions. Don't send me the answers for the mock test. Do it in your notebook, and on Monday I will review the answers with you, and then you can see whether you've learned something. And I'm also going to show you the next video I'm going to upload is also for those of you who left your textbooks in the locker at school. I don't know, some of you did that probably. I have a feeling you did. So I'm going to send you a video. So the next video for this class, I'll show you the questions in the book. So you could just look at the video to see what the questions are in case you forgot your book. Okay, so I'll see you Monday.